With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So today we are going to discuss one question on triangles. So here in this question we are given the four different subparts. So here in the first part they have given us to state that what is the basic proportionality theorem in case of triangles. In the second part they have given us to state that what is the midpoint theorem in triangles. And in the third part they have given us to state the basic Pythagoras theorem in triangles. And in the fourth and the final part they have given us to state the conditions for the similarity of two given triangles. So here we need to state all of these four parts. So let us try to focus on the first part here. So in the first part they have given us to state the basic proportionality theorem. So here in the first part we have to state the basic proportionality theorem. So here we have the basic proportionality theorem. The basic proportionality theorem. So for understanding the basic proportionality theorem we should need a triangle here. So let me draw a triangle here first. So here we have a triangle. Let us say that this is a triangle, the triangle ABC. So let us name it. So here we have the vertex A, this is the vertex B, and this is the vertex C, and this is a triangle ABC. Now in this triangle ABC, let us assume that we have a line which is parallel to one side or the one base of the triangle. So let us say here we have the side BC. We are considering the BC side, and we have a line PQ which is parallel to this BC side. So here we have the line PQ like this. So let us say that this is the line PQ. So here we have the point P and this is the point Q, and here we have the PQ as parallel to BC. So here this basic proportionality theorem, that is the BPT. So here we have the BPT. The BPT, that is the basic proportionality theorem, states that this theorem states that if in a triangle we have a line which is parallel, if that line is parallel to one side or the base of the given triangle, then in such a case that parallel line, that given parallel line would divide, that given parallel line would divide the cutting sides of the triangle, the cutting sides of the triangle in same proportion, So now let us try to understand this theorem which we have stated here by using this given triangle ABC. So in this given triangle we have considered the base BC, and we have a line PQ which is parallel to this base BC of this triangle. Now if in a triangle we have a line which is parallel to one side of the triangle, then if that line PQ cuts the AB and the AC sides of the triangle at the points P and Q, then those points, that is the point P and Q, would divide the AB and the AC sides, that is the cutting sides of the triangle, in the same proportion. So here we have, according to this BPT states that if we have the PQ parallel to the BC side, then in such a case we can say that the P and Q would divide the cutting sides of the triangle in the same proportion, that is this point P and the point Q would divide the AB and AC in the same proportion. That means the AP upon PB, here the AP upon PB would be equals to the AQ upon QC, So this is what this BPT states here. So this is the thing which basic proportionality theorem, that is the BPT, states in this triangle. Now we are going to consider the next part of the question. So in the next part of the question we need to state that what is the midpoint theorem. So now we are going to focus on that. So here we have to state the midpoint theorem. So here we have the midpoint theorem. Now again, for stating that what is the midpoint theorem, we need a triangle. So let us draw a triangle here. So now we are again going to draw the triangle. So let us say here we again have the triangle ABC. So here we have the triangle ABC. This is the vertex A, this is B, and this is C. So here this midpoint theorem, that is MPT. So here this midpoint theorem, that is MPT, states that this MPT states that the line segment joining the midpoints, the line segment joining the midpoints of two different sides of the triangle, of two different sides of the triangle, of the given triangle, would be, that line segment would be parallel to the third side of the triangle, to the third side of the triangle which we have not considered, and that line segment is half in length, to the third side of the triangle, to the third side of the given triangle. So now let us try to understand this MPT by using this given diagram, by using this given triangle. So we know that this MPT states that the line segment joining the midpoints of two different sides of the triangle. So here we have the midpoints of two different sides of the triangle. So let us consider the two different sides of the triangle as the AB and the side AC. So in this we have the two different midpoints of these two different sides. So let us say that here we have the point P, the midpoint of this AB side, and here we have the point Q, the midpoint of this AC side. So here we have the PQ line segment. So here we have the PQ line segment like this. And since P is the midpoint of this AB, so this AP would be equals to this PB. And here we know that since this Q is the midpoint of AC, so this AQ would also be equals to this QC in length. So here they have stated that the PQ line segment, that line segment would be parallel to the third side of the triangle, and that third side is the BC side. So if all of these given conditions holds true, then this PQ side length, then this PQ side would be the parallel to the third side, that is the BC side. And it is also given that the line segment, that is the PQ side length, is half in the length of the third side of the triangle, that is this PQ would be equals to the BC by 2 in length. So here this theorem states that if P and Q are the midpoints of the AB and the AC side, then this theorem states that the PQ would be parallel to the BC. Here the PQ would be parallel to the BC, and along with this also states that the side length PQ would be the half in the measure of the third side of the triangle, that is the BC by 2. So this is what this given theorem, that is the midpoint theorem, states here. So this is the statement of the midpoint theorem, that is the MPT theorem, which we have written above. Now after this we are going to focus on the third part of the question. So here in the third part of the question they have given us to state that what is the Pythagoras theorem. So now we are going to consider it here. So it is a very simple theorem. Now we are going to study that what is the Pythagoras theorem. So in order to study that what is the Pythagoras theorem, we again need a triangle, and that triangle should be the right angle triangle. So here we have the triangle, so let us draw it. So here let us say that we have the perpendicular of the triangle, and here we have the base of this triangle, that right angle triangle, and here we have the hypotenuse of that right angle triangle. So let us say that this triangle is the triangle ABC, right angled at the point B, like this. So here we have the ABC triangle. So this Pythagoras theorem states that the Pythagoras theorem states that this Pythagoras theorem states that the square of the hypotenuse of the right angle triangle, of any right angle triangle angled triangle would be equals to the sum of the squares, the sum of the squares of the height, that is the perpendicular, and the base of the other two sides, So this is what this Pythagoras theorem states that. So according to this Pythagoras theorem, if we understand this Pythagoras theorem by using this diagram, that is this given triangle ABC, right angle at B. So according to this Pythagoras theorem, the square of the hypotenuse, that is, here we have the hypotenuse as the AC. So here we have the square of this hypotenuse, that is the square of the AC, would be equals to the sum of the squares of the other two sides, that is the sum of the squares of other two sides, that is the AB square plus BC square. So here we have the AB square plus BC square. So this is what the right Pythagoras theorem states here. So this is the statement of the Pythagoras theorem, which was asked to us in the third part of this question. Now after this we are going to focus on the fourth and the final part of the question. So in the fourth and the final part, they have given us to state the conditions for the similarity of two triangles. So here we have the conditions of the similarity of two triangles. So in the fourth part we state the conditions of the similarity, the conditions for the similarity of two given triangles, So here we are going to study that. So here in this case we have the four different conditions, the four different criteria of the similarity of two given triangles, and in order to study all those four similarity criteria, we should need the two triangles here. So now we are going to draw the two triangles. So let us say here we have the triangle 1 and here we have the triangle 2. So here we have drawn the two given triangles. So let us say that this first triangle is the triangle ABC, like this, and this second triangle is a triangle PQR. Now we are going to study the first condition. So the first criteria of similarity is, here we have the first criteria of similarity as the angle similarity criteria. So here we have the angle similarity criteria. So in this angle similarity criteria, we have, if we have two different triangles, and in those two different triangles, if we have the two corresponding angles of those triangles as congruent, then we can say that those two triangles would be similar by using the angle similarity criteria. So here let us try to understand this angle similarity criteria by using these two triangles, that is the triangle ABC and the triangle PQR. So here, if we know that if the angle A is equals to the angle P, and along with this we have the angle B as congruent to the angle Q, then if any two angles, we have taken the angle A and angle B from the first triangle, and we have taken the angle P and angle Q from the second triangle. So if any two given triangles, if any two corresponding angles of the two triangles are congruent, that is they are equal, then we can say that those two triangles would be similar by using the angle similarity criteria. So here we have, if this condition holds true, then we can say that the triangle ABC, here the triangle ABC is similar to the triangle PQR. This is what the angle similarity criteria states here. Now we are going to study the second similarity criteria, that is the AAA similarity criteria. So here we have the second similarity criteria is the AAA similarity criteria. So this AAA, that is the angle similarity criteria, states that if in any two given triangles, if all the three angles, the three corresponding angles of the two triangles are equal, then we can say that those two triangles are similar to each other by using this angle similarity criteria. So here, if in these two triangles, if we say that if angle A is equals to the angle P, and along with this the angle B is equals to the angle Q, and the third condition, third and the final condition is that the angle C is equals to the angle R. If all of these three conditions holds true simultaneously, then we can say that the triangle ABC would be similar to the triangle PQR. So here we have the two triangles, and in these two distinct triangles we have all the three corresponding angles as equal. That is, the angle A is equals to the angle P, the angle B is equals to the angle Q, and this angle C is equals to this angle R. Then we have the AAA similarity criteria. Now after this we are going to study the third similarity criteria, that is the side angle side similarity criteria. So here we have the third similarity criteria. So here we have, let us say, here we have the third similarity criteria, and that third similarity criteria is the side angle side similarity criteria. Now we are going to study this. So this SAS similarity criteria states that in two given triangles, if any two sides of the triangle, if any two sides of the triangle lies in same proportion, and along with that the included angle, the included corresponding angle in those two triangles are congruent, then we can say that the two triangles are similar to each other by using the side angle side similarity criteria. So let us try to understand this third SAS similarity criteria by using this diagram. So here in this diagram, if we consider the two sides, any two sides of the triangle, so let us consider the AB side and the BC side, and the corresponding sides of this triangle would be, let us say, the PQ, and here we have the QR. So here if these sides are lying in the same proportion and the angle included between them, that is the angle B and this angle Q, are congruent to each other, then we can say that the two triangles are similar to by using the SAS similarity criteria. So here we have, if we have the AB upon, here we have the PQ is equals to the BC upon QR, if this holds true, and along with this if we have the angle B congruent to the angle Q, the angle enclosed between the two given sides, then we can say that the triangle ABC would be similar to the triangle PQR by using the SAS similarity criteria. Now at last we have the final and the last similarity criteria, that is the SSS similarity criteria. Here we have the SSS similarity criteria. Now in order to understand this similarity criteria, we are again going to consider the above given two triangles. So if in any two given triangles, if all the corresponding sides of the triangles lie in same proportion, then we can conclude that the two triangles are similar by using SSS similarity criteria. Then only we can conclude that the two triangles are similar. They are similar by using the SSS similarity criteria. So if we consider these two triangles, then all the three given sides of these two given triangles should be proportional to each other. If this happens, then they are similar. So this means that the AB upon PQ would be equals to the BC upon QR would be equals to the AC upon PR. If this happens, then they are similar. So here we have, if the AB upon PQ is equals to the BC upon QR is equals to, here we have the CA upon RS. If all the three sides of the given triangles are lying in the same proportion, then we can say that the triangle PQR is similar to the triangle ABC by using the SSS similarity criteria. So here in this question we have stated all the 4 different theorems which were given to us in this question. So this is our solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.